a diagonal line. The y-intercept is -1. It moves up 1 over 1.
You actually put a square on the wall.
Thank you, Isaac.
Oh, I didn't.
It was not an accident. Okay, pretend that line goes through that point.
Can it be an accident?
And you could pretend there's not a square on the y, but you'd be wrong there. So this, what shape is it since it does have a square? It is a parabola, but this is not an up or down parabola. This is a sideways parabola. Mhm.
Can you just do square root of 2x plus
Okay.
It's the same thing as.
So you could do the
positive,
square root of 2x plus 6 and
negative.
negative square root of 2x plus 6? Okay.
It's the same way.
I'm all right with that. That's not the approach I was going to take, but I'm all right with that. You've got to be able to graph it. So whichever way you want to go with to graph it sounds good to me. How are you going to graph that? Okay, plug in some points.
Oh, wait.
That'd be-
Can you do it a different way? Can you just solve for x and
I was going to suggest that we find x-intercepts and y-intercepts.
True.
We'll go back and do that in a minute if you want to. Could we do the same thing here? Find x and y-intercepts? Wouldn't they be the same thing? So either way that you want to do it, find the x and the y-intercepts. To find an x-intercept, what do you plug in?
Oh,
0 for y. So you can do it either way you want to.
So just say.
Set either of these equal to 0. Either these two or that one. So when you use y equals 0, what do you end up? You get 0 squared equals 2x plus 6.
So that'd be -3.
Yeah. So that gives you x equals -3. So isn't -3, 0 going to be a point on this sideways parabola?
Yes.
Okay, great. Now, do you remember about parabolas? Which way is this going to open?
To the right.
It's going to open to the right.
Yeah, because
So we know that this parabola is going to go this way.
So you can find your y.
So I found my y-intercepts now. And you can do that using either these two graphs or that one. Either method that you would like to choose is fine. So now I'm going to use x equals 0. Wouldn't that give me positive and negative square root of 6? What is that in between? What two whole numbers is that in between? Between 2 and 3? It's going to be somewhere in here and somewhere in here. So this is enough for me to sketch this parabola. But what do I need to actually be able to find now? The intersection points. So to find these intersection points, you're going to have to use this system of equations and solve it. You've got to figure out where these two graphs are the same, where they have the same points, right? So you could do substitution. Graphing didn't work for us. Or you could do elimination. That won't work because of this y squared. So you're going to have to do substitution. So what can I substitute into this problem for y?
X, Y, Z.
Y is x minus 1. So that means I could now have an equation that says x minus 1 squared equals 2x plus 6. All right, so let's solve this equation. I get an intersection that's going to occur where x is 5 and also where x is -1. Does that make sense graphically?
Yes.
Yes? So I need to find these points. This is going to be 5 something, and this is going to be -1 something. Does it matter which equation I plug it back into to find the y?
No, so just put it into the x.
Put it into the easiest one. So if I put in 5 right here, 5 minus 1 gives me 4. So that intersection point is 5, 4. This intersection point is -1, -2. Thank you. So now I have this region that is bounded by those two graphs, but do I have one function that's on top of the other function for the entire interval? No. For this little region right here, isn't the same function on the top and the bottom?
Yes.
Do you see that? See this parabola? I'm going from here to here. Again, at this section, isn't it the same graph that's the top and the bottom? Well, you can't use the same graph to subtract top, subtract bottom.
You can, use the intersect point sentence, where the intersect point is, draw a vertical line and then solve for the area of the, but instead of minusing, integral, wait.
I could find this area doing top minus bottom, couldn't I? But this part over here is tripping me up. I
Wait.
would not have a way to do that.
Yeah, you can, because y squared equals 2x plus 6 is the same as y equals square root of 2x plus 6. But that will only have the top part, and then you need the bottom part. So you'll take the integral of square root of 2x plus 6 from,
So you're now using these two functions
yes.
and calling this square root of 2x plus 6 and this negative square root of 2x plus 6. So then that's not using the same equation as what I said over here. You're splitting it up into two separate ones. Okay, so you can do it that way. You could split this up into two different regions. You're going from -3 to -1, top minus bottom, and then -1 to 5, top minus bottom. There's an easier way. You do not have to always use x as your variable. Instead of saying top minus bottom and using x as my endpoints,
Left minus right.
could you do right minus left and use y's instead? Is there a particular formula that is on the right side of this region? Isn't that blue line always to the right of the yellow curve?
It is, yeah.
Yes. So instead of integrating with respect to x, I could do this whole problem in terms of y's instead. So that would mean that I would want to integrate from what is my low y value. And my higher y value. And I'm doing this with respect to y. So what does that mean these equations need to be now in terms of? X equals something in terms of y. So what would this equation be in terms of y? Y plus 1 equals x. And is that my right or my left?
That's your blue.
That's the blue one, so that's the right function. And then if I were to solve this in terms of x, that would be, and then you said 1/2 of it? Yeah, so y squared minus 6 divided by 2, or 1/2 of that, either way. And now, isn't that my right function?
Yeah.
No, left.
Yeah.
You know the difference in left and right. This is your left function, the blue one was your right. So now when I get ready to subtract these, I'll take y plus 1, and then subtract from it. I'm going to go ahead and separate it as 1/2 y squared minus 3. Is that mathematically legal? Yeah, you can break that fraction up that way. So now if we keep going, I would have y positive 1 minus -3. Would that turn into 4? Minus 1/2 y squared. I just like to combine those like terms before I integrate. It means less integrating. Anybody verify I did that correctly? Okay.
Well, you have to do y prime.
Now we need to, not y prime, we need to integrate. What's up, Austin?
What happened from the one?
When I added 1 to that, that became y cubed, and 1/2 divided by 3 turns into 1/6.
The first half.
The 1/2.
You like figure that out.
Oh, I need to put in a 1/2. I got you. Yes, you're right. Bring me that bonus point back. You have 2.
Yes.
Can you plug in your 4 and your -2 and evaluate this? Use a calculator just to save some time so that you can do this quickly and we can see if we get the right answer.